All right, Algebra 1, we have got Chapter 9, Section 5, Permutations and Combinations. This is a math buffet, and I say that because I think of a buffet when I think about combinations, and so I walk up to it, and there are many different options. And the smaller the buffet, hey, I could try a little bit of everything. Obviously, the larger of the buffet, I only get to select just a few items because there's only so much room in my stomach. So let's talk about permutations. Permutations begins at its basics and looks just like this. So we're going to go, a permutation is n items selected n number of times. So that would be something like I go to the buffet and there are 5 choices and I'm going to eat all 5 of them. So that's going to be 5 items to choose from, and I'm choosing all 5. And so what that looks like is what's called a factorial. And this is said in factorial. And what a factorial is I just take, starting with the number 5, and once I have selected one item, then for my next selection I have 4 to choose from, then I have 3 to choose from, and all the way down. You can include the 1 or not because it's just going to be multiplication. But this is the same thing as 5 factorial, which means 5 times 4 times 3 times 2 times 1. So I'm at a buffet, it has 5 options, and I try one of each of them. So I ask myself, how many different ways could I try those 5 items? So I multiply those together. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So I could go in 120 different orders of selecting 5 different items. So it seems like a lot, and it is, obviously, but if we have, oh, and I don't know if I multiply that by 1, but it's still going to be 120. So that's a 5 factorial. Now, what if I go to a bigger buffet and I have, let's say 15 items, but I still will only be able to choose 5 because I just don't have enough room to do that. So in this case, this is going to be the 15 factorial on the top, and then I'm going to subtract those two numbers, and take that factorial. So 15 minus 5 is 10, so this is 15 factorial over 10 factorial. Now, I'm going to go ahead and write this out the long way. I'm going to do this one time, and it's going to take me a couple of seconds, so I'll be right back with you. And this is what we come out with, and you can go ahead and hit pause on that one if you would like, and go ahead and write that. So again, 15 factorial over 10 factorial. So remember, with fractions, I can simplify things that are on top and bottom, so I can eliminate 10 factorial just like that. And so what I'm left with is 15 times 14 times 13 times 12, and I don't know where my 11 went. Should have been 11 in there. Sorry about that, guys. Okay, so 15 times 14 times 13 times 12 times 11, and again from that point on, my 10 goes away. So now I'm just going to break out my calculator, and I have 15 times 14 times 13 times 12 times 11 times 10, and I end up with I end up with 3,603,600 different combination of, different permutations of food items if I have 15 items and I am only selecting 5 of them. So that's pretty crazy when you think about it, when you think about the overall choices. And we're going to do a little example in class when we discuss this that will really open up your mind. So now let's go to combinations. Permutations, which we just got done with, is where order is important. In a combination, order is not important. And a combination is going to look something like this. Okay, so let's say I have 8 things to choose from, and I'm selecting 2 of them. And order is not specific, so I can select any 2. Doesn't make any difference. In our last one, remember we were selecting 5, so that 5 was a little bit more specific. So we are looking at n factorial. All over n minus r factorial times r factorial. Okay, so in this case, that's going to be 8 factorial over 8 minus 2 factorial times 2 factorial. So the 8 minus 2 is going to end up being 6 factorial times 2 factorial. So what that's going to look like, and I'll leave this going here, we don't have to pause. We're going to have 8 times 7 times 6 times 5 times 1 all over 6 times 5 times 4 times 3 times 2. That's a great 3 times 1, and then times 2 times 1. So I'm going to take this 6, 5, 4, 3, 2, 1 and get rid of that. Now this opens up something interesting. I have 8 times 7 all over 2. Okay, I didn't put the times 1 on there. We can cancel in. That 2 goes into that 8 4 times. And so 4 times 7, that's going to give us 28 options if we are doing combinations where we have 8 to choose from and we are choosing 2. So again, formula is n factorial over n minus r factorial times r factorial. And that's about 8 minutes, and that is 9-5 permutations and combinations.